The Sentinel Protocol, why the moon was always a warning. The shadow held, razor straight against the moon's far side, refusing to wobble, refusing to drift. Our own numbers flagged it as a formation, not a rock. 3 sharp points, evenly spaced, sitting where no normal relay should be. In the control room, people argued glare, compression, artifact. Then the second pass matched the first, same edges, same spacing, same cold silence. If it's built, it isn't sightseeing. It's policing. Here's the part that lands hard. We keep seeing the same triangle, the same timing, the same polite interference when our launch traffic spikes. Not chaos rules, quiet rules, the kind that nudge, mute, and reset without asking. Tonight, we'll connect 3 threads. Whispers and odd gaps dating back to the 1970s, new Space Force language about orbital anomalies, and a simple triangle pattern hiding at the balance points between Earth and the Moon. No equations, just clear pictures and plain timing. By the end, you'll have to decide, is the Sentinel Protocol shielding Earth, or quietly caging us? To understand the Firewall, we go back to the moment astronauts first heard the hum on the far side, and controllers learned to treat silence like a message. The 1970s silence breaks. On paper, Apollo's farside windows were routine, loss of signal scheduled. In practice, people circled them in red. Every loop behind the moon dropped communications into a quiet too perfect, an engineered kind of empty. The public transcript called it LOS. Inside mission control, the notes used a different phrase, persistent echoes. Stakes first. What if the strange gaps around the far side weren't just geometry and timing? What if the interference clustered at altitudes above lunar orbit, as if something outside the stack, and outside the plan, kept touching the line every time the capsule slipped into the shadow? What if the silence wasn't empty at all, but a message written as a pause? The net above us, Lagrange points as chokeholds. While that was buried on Earth, the geometry above us never moved. 5 balance points hang in the Earth, moon system like knots in a rope, L1, L2, L3 on the line, and the twins, L4 and L5, 60 degrees ahead and behind the moon. They're not places you land. They're places you linger, if you know how to lean on gravity the way sailors lean into wind. Small pushes keep you there. Small stations see everything. Here's the simple version. Think of these points as natural rest stops, where spacecraft can hang out with very little fuel. L1 sits between Earth and the moon, like a toll booth for everything going out. Most trips to deep space pass that way. L2 floats beyond the moon's far side, tucked in the moon's shadow, out of our direct sight and outside normal relay lines. Park there, and you can watch the far side and the deeper lanes without being easy to see from the ground. L3 is the mirror point on the far side of Earth, mostly a math curiosity. L4 and L5 are the quiet balconies, sitting at the corners of an invisible triangle with Earth and the moon. They're calm enough that even dust can gather, calm enough to hold history. Why does this matter? If you wanted a small net that could touch every path to the moon with the fewest posts, you would string triangles between these points. L1, L4, L5 faces Earth. L2, L4, L5 covers behind the moon. Equal spacing lets you find positions fast using timing and angles without chasing targets. 3 points, clean timing, simple math. It's GPS turned inside out. Action first, then the human piece. In the late 1970s, a contractor in a beige cubicle outside Houston ran a side simulation no one asked for. His job was boring. Design good relay coverage for pretend science craft. His result was not boring. He modeled a 3-node setup using L4, L5, and a loop around L2. The solution showed non-stop coverage of the far side, tight tracking of anything passing the L2 lane, and passive distance checks on objects across a big Cislunar shell. He wrote it up, stapled it to a funding request, and dropped it in the mail. 3 weeks later, he got a tidy rejection. Programmatic alignment unclear. Next quarter, his budget code vanished. Here's what most people didn't know. Lagrange points aren't tiny dots, so much as calm zones where you can drift in looped paths. You don't park like in a lot. You drift in gentle flowers called halo paths. For sensing, that's perfect. A little motion gives you depth without moving the whole setup. A node at L2 can nod slightly, while keeping the moon between it and Earth. Nodes at L4 and L5 can see each other and the lanes below without burning fuel. And everything we launch has to pass through the same few funnels. The net never chases. We do. The big idea? This triangle logic at these points matches the triangle patterns people report seeing below. Equal spacing, same angles, calm formations that look like craft but act like anchors. The same template appears at different sizes because the math is the same. If your goal is to know where things are, gently steer links and quiet loud signals. 3 small posts beat 1 huge platform. They also fail safely. Remove 1, and 2 still help when the timing is right. Add a 4th, and you get sharper answers. And if a system wanted to quiet our loudest broadcasts so the galaxy hears less than we shout, L2 is the crown seat. Hidden from us, loud to the rest of space. Microstory. A breakfast diner off NASA Road 1. Cracked vinyl. Coffee that never ends. Our contractor sits with a folded printout. Triangles and pen. L2 circled twice. 2 colleagues slide into the booth. One lowers his voice and says he heard a word in a corridor nobody uses in public. Sentinel. They laugh it off. Minutes later, the contractor checks his request. His terminal blinks. Access denied. By afternoon, his project folder has a new owner and a new title. Orbital Communications Harmonization, Phase 0. He isn't invited to Phase 1. Across the ocean, astronomers publish quiet papers on how to hover at L1 and L2 using tiny thrusts. Space agencies plan farside radio arrays that need a relay at L2 to whisper through the moon's bulk. The public diagrams look like telecom homework. The private takeaway is obvious. Anything that can relay can also watch, and anything that can watch can also gate. This was the moment everything changed. Once you accept those 5 balance points exist whether you care or not, the pattern takes over. Launches climb, traffic surges, and the cleanest place to manage chaos is at the knots. If a protocol wanted to police lanes, it would choose these seats. If a firewall wanted to shape what leaves and enters, it would sit behind the moon and at those 2 quiet balconies, equidistant, unblinking. In the aftermath, our word stayed earthbound, relays, comms, exploration. The geometry didn't care. It kept holding its triangles overhead, waiting for us to notice the net doesn't need force to run, just timing and a reason. Signals that wouldn't die, 1980s intercepts and ghost pings. From geometry to sound. While public attention stayed on rockets and flags, the listening posts took the night shift. In the early 1980s, a signals officer at a quiet Pacific site started logging a tone that didn't fit any catalog. Not a beacon, not a satellite signal, not radar spill. It was a metronome with manners, clean spacing, same rise, same fall, like it was built, not natural. He wrote, unknown cadence, non-terrestrial timing base in the margin. His supervisor crossed out non, told him to file it under space weather. Here are the stakes. If a pattern repeats at moon distance, stays cleaner than most commercial systems, and shows up only when certain orbits go busy, you've got 2 choices. Either we built something we didn't admit, or someone else did, and put it where we pretend only gravity sits. The officer noticed one more thing. The pings clustered when Cislunar launch windows stacked, especially during long burns that crossed the Earth-Moon line. He didn't know the word Lagrange. He learned by listening. Other stations started hearing the same thing. Greenland, Guam, a desert array in Australia. Each site recorded short bursts, 3 pings, then silence, with very steady timing that shifted a little, like the source was moving around the moon. When the moon set, the pattern faded. When it rose, the pattern returned, but not at the same clock time. Operators compared notes over bad coffee and radios that weren't supposed to cross-link. They called them ghost pings because nothing plotted on a map. You couldn't triangulate from Earth. The angles were wrong. The distance felt trapped behind the far side. Action, then a human moment. Night watch, fluorescent hum. A printer fighting a stack of green bar paper. The system flags a sequence. 9 pings, same spacing, then a gap equal to 3 spacings, then 9 again. The officer prints it and walks it down a corridor. At a door marked with a numbering scheme only base supply could love, a civilian in a plain sweater takes the paper, thanks him, and says, "We'll reconcile the clock drift." It sounds helpful. Next morning, the officer checks the archive. The file is there, time-stamped, labeled, but the waveform is blank. A perfect rectangle of white where the signal used to be. People in other fields saw the same kind of structure. Radio astronomers scanning low bands for space, weather found repeating features where the sun shouldn't be. Microwave engineers testing antennas heard a faint comb on nights when the moon sat high. A naval site tracking deep space noted unexplained ranges, in Cislunar returns that went away when someone called it ionospheric. Meanwhile, the ghost pings kept their manners, clean, periodic, modest power. Like a lighthouse you only see if you know when to look. This was the moment everything changed, though nobody said it out loud. Engineers built filters to strip the pings out of routine data. Schedulers learned to avoid certain windows if they wanted clean baselines. The phenomenon became maintenance, not mystery. But the pattern didn't quit. When heavy traffic headed toward the Earth, Moon line, the pings got stronger, like a network upstream woke up to take attendance. When a bad debris scare hit high orbit, the pings changed tempo, then calmed. No official link. Just operators keeping private notebooks. Impact. A few analysts stacked the ping intervals against models of a node near L2 sweeping a beam, while timing passes across L4 and L5. The math lined up. Not classic radar. More like a handshake between clocks. Status checks inside a system, making sure its edges match. The ghost pings sounded less like messages to us, and more like the network talking to itself. Microstory. A junior tech at an inland site notices the printer jams whenever the pings hit. Not random. The data buffer overflows when the filter kicks in. She clears the queue and watches a single sheet slide out with half a waveform before the blanking routine erases the rest. She tucks it into a book and forgets it. Years later, moving day, the sheet falls out. The time code at the top matches a launch she watched on TV. The intervals align with a tranlunar injection burned to the minute. Meanwhile, official language hardened. Air Force reporting forms added boxes for orbital anomalies. A note reminded operators not to use the phrase non-human. The all-domain office later echoed that in public testimony, but behavior on the floor told the truth. Everyone planned around the pings. You don't plan around artifacts. You plan around actors. In the aftermath, the listening posts did what they do: listen. The ghost pings never declared intent. They never turned into speech. They just framed our busiest moments with a quiet metronome that matched cislunar geometry too neatly to ignore. And as the decade turned, the same signals officers wore patches that said Space Force. They weren't arguing if the pings were real. They were writing playbooks for when the pattern changed. Space Force changes the language. By the time the ghost pings became part of the night shift's weather, the uniforms changed, and so did the verbs. Track turned into characterize. Interference turned into anomaly. Inside briefings, the phrase unattributed behavior replaced every guess anyone wanted to say out loud. Then a document landed with the weight of bureaucracy. The Space Force's Data and Artificial Intelligence Strategic Action Plan for 2025. On the surface, it read like culture change, governance, literacy, partnerships. Between the lines, it sounded like survival in an environment that refused to be cataloged by legacy models. Stakes first. If the service in charge of orbital order starts teaching every guardian to speak AI, it's not about buzzwords. It's because the sky is producing more signals than humans can parse, and some of those signals don't behave like debris, satellites, or meteorology. The plan mandated AI fluency, not optional training. Operators needed systems that could notice patterns across orbital layers in real time. Surface sensors, mid-atmosphere returns, orbital tracks, and cislunar transits. Then correlate them with the unknowns without jamming every feed with false positives. You don't restructure your force to chase noise. You adapt to an opponent you won't name. Action. March 2025, the plan goes live. For lines of effort, clean data, teach everyone, field analytics fast, plug into industry and allies. The internal translation at unit level was simpler. Fuse every camera, radar, telescope, and commercial feed you can lease. Let the machines flag what your doctrine doesn't recognize, don't miss. Contracts rolled out to tie in commercial constellations, wide-field ground sensors, and private radar. A guardian at a mountain site watched a new dashboard bloom with tiles: air, orbit, geosynchronous, cislunar, each colored by an anomaly score. The pings he'd been trained to ignore now had their own lane, scored, time-stamped, cross-checked with launch schedules he didn't have clearance to see. Microstory. Utah Valley, winter dust settling on pasture fences. Before dawn, unmarked vehicles slid in with masts that rose like bare trees, portable arrays, self-contained. Locals filmed from kitchen windows. The team put down cables, powered up, and the valley hummed with a tone no one could hear, but some people felt. Hours later, witnesses caught 3 luminous points holding a triangle low over the ridge, steady in a way wind can't explain, then fading. The next day the gear was gone, grass laid flat where it stood. Officially, nothing happened. In the logs, that valley now had a tag and an anomaly trendline. Meanwhile, testimony stayed cautious. The all-domain office repeated the familiar line: no verifiable evidence of extraterrestrial technology. The Space Force didn't contradict them. It didn't have to. Behavior tells the truth quicker than language. New playbooks circulated for orbital anomaly management, a phrase that puts a leash on panic. Procedures detailed how to maintain comms continuity during non-cooperative interference without attributing source. Another section described temporary no-fly slivers during spectral congestion events. In practice, it meant commanders had authority to clear lanes when the net tightened. Nobody used the word Sentinel. They didn't need to. What nobody outside the fence knew was how quickly the machine correlations changed day jobs. A Guardian in Colorado watched an AI layer stack ghost pings, L2 geometry, and civilian interference reports into a single timeline. The system would nudge an alert when launched traffic on one coast increased the anomaly score over the far hemisphere minutes later. It felt like seeing weather fronts where the map used to be a blank. He printed nothing. Paper had a way of getting lost. This was the moment everything changed, though it looked like normal staff work. The service published guidance on multi-layer anomaly adjudication, teaching crews to treat the unknown like a managed participant. Deconflict, buffer, resume. Commercial partners got letters about cooperative spectral stewardship and quiet upgrades to their telemetry pipelines. Universities found themselves invited to join experiments on non-kinetic resilience during busy windows, the kind of phrasing that soothes when what you're doing is bracing for a hand you can't see to press into the network. Impact. Language shifts became rules. Orbital anomalies is a phrase that admits persistence without conceding origin. AI literacy requirements turn intuition into workflow. Don't argue the ghost pings, measure what they do to your links. The partnerships bring civilian sky feeds into the same room as classified tracks, giving the machine the widest lens possible. And beneath the denials, deployment patterns draw a silhouette. Arrays in valleys before orbs appear. Temporary comm reroutes when L1 and L2 corridors go busy. Drills that rehearse keeping aircraft safe while overhead geometry holds steady and unreadable. Microstory. Night shift briefing at Vandenberg. A captain points to a strip of airspace and says, "Expect congestion not reflected on public schedules." The room stays quiet. Pilots adjust fuel plans. Controllers mark windows. Nobody says why. Hours later, 3 steady returns hang too still to be weather, too quiet to be traffic, and exactly where the machine said they'd be. Everyone goes home on time. Nothing to report. In the aftermath, the Force didn't claim a discovery. It normalized a posture. Train the people, wire the feeds, let the machine surface the patterns, write procedures around the behavior, and keep the nouns bland. By changing the language, they gave operators a way to act without a speech about what's up there. Which of course leads to the next reveal. When the moon becomes the quiet center of a loud sky, you start noticing when the corridors through L1 and L2 run hot. The 2026 wake-up, lunar corridors go hot. It started as nuisance reports from companies that never admit nuisance. Telemetry hiccups on tranlunar trajectories. Star trackers drifting off solutions for seconds at a time. Narrowband comm links losing lock exactly as vehicles cross the invisible line between Earth and the Moon. Internally, project managers wrote, "transient interference." Externally, press releases said nothing. But by late winter of 2026, the pattern wouldn't stay quiet. The trouble clustered wherever routes brushed the L1 and L2 neighborhoods, and it kept the same strange manners the ghost pings had. Precise timing, polite intensity, surgical brevity. Stakes first. These weren't low-orbit dropouts you blame on crowding. These were degradations on the highway that carries every serious mission outward. If the corridor through L1 sneezes, payloads miss burns. If the L2 shell coughs, relays behind the moon go dark. One misstep at those knots doesn't strand a satellite. It changes the calendar. That's money, insurance, and careers. It's also tacit admission that something with rhythm sits at the balance points and responds when we make noise. Action. In January, a commercial lander consortium logged a string of attitude excursions as their vehicle climbed past high elliptical apogee toward translunar injection. The excursions mapped to micromomentary star tracker blindness lasting less than a second. The path crossed the L1 funnel. The engineers scrubbed, recalibrated, and flew again. Same behavior, same altitude band, different time of day. In February, a National Space Agency testbed, riding a free-return arc, reported unexpected spectral congestion on a deep space transponder during a pass through the L2 approach. The signal wasn't jammed. It was gently crowded, like a hand resting on a microphone. The ground switched to backup and rode it out. Meanwhile, privately, operated telescopes started flagging something that didn't belong on their screens. Not objects, gaps. Narrow, temporary holes in background radio quiet that tracked with translunar traffic like wakes behind a boat. An academic lab in Europe published a dry note about transient line-of-sight obfuscations consistent with structured interference. It was paywalled, dull, and read by exactly the people who needed to read it. A week later, the lab retracted the note and replaced it with a study about antenna calibration. Microstory. A Starship test climbed out of Boca Chica on a heavy day, booster thunder rolling the Gulf flat. The ascent went clean, the stage did its ballet, and the upper vehicle settled into a parking orbit. Minutes later, as engines lit for the long push toward the moon, 3 steady points formed above the band where space looks like sky. Not stars, too steady, not vehicles, too quiet. Phones caught them from a dozen angles. They held their equidistance, softened and dissolved. The mission proceeded, but the ground reported a brief need to switch frequency. The timeline said nominal. Here's the cadence that broke denial. Every burst of launch activity, every window where multiple vehicles raised orbits towards Cislunar, brought a rise in anomaly flags around L1 and L2. The flags weren't random. They tracked with our schedule, like a metronome we didn't set. A rideshare flight to high orbit produced a small blip over L1. A pair of geosynchronous deliveries stacked close together produced a bigger one. A cargo mission to a near-rectilinear halo orbit behind the moon produced the largest, centered on the L2 approach, with sidebands that looked suspiciously like handshake tones. Operators adapted. Procedures shifted to include short, pre-planned comm handoffs just before vehicles entered the sensitive shells. Mission control floors posted timing cards that looked like blackout schedules, except nothing went dark. Everything went prudent. The Space Force dashboards rolled anomaly heat maps into the planning tools, so commanders could buffer busy windows. No one called it deconfliction with a non-cooperative participant. They called it resilience. The effect was the same. We moved around something that didn't move for us. Impact. The response exposed intent without a confession. If the Sentinel geometry wanted to harass, it could drown links, not nudge them. If it wanted to hide, it could stay invisible, not paint faint triangles that the public can film. Instead, the behavior looked measured and conditional. When our traffic surged, the patterns tightened. When a collision risk rose in high orbit, the interference in cislunar space briefly increased, then fell away faster than models. It acted like a network enforcing rules on a lane, not like a fleet playing games in the sky. Microstory. A flight dynamics team at a private firm watched their tools throw unmodeled acceleration warnings during a tranlunar injection. The numbers were tiny, like a breath on a pendulum, but the timing lined up with a known anomaly window over the L1 corridor. Their lead wrote a note to clear the flags and ran the burn longer by a sliver. The trajectory settled back onto the line like a coin dropped into a groove. Weeks later, he looked at his own change log. He had written, compensated for corridor weather. He had never used that phrase before. Meanwhile, insurance underwriters adjusted fine print to include network-induced comm degradation. Launch brokers added a new disclosure question about corridor timing. Academic telescopes tuned their surveys to avoid low-frequency bands during heavy cislunar traffic, citing self-generated interference. The language stayed bland. The behavior wasn't. Everyone acted as if something upstream noticed our pushes and responded with gentle gates. This was the moment everything changed because it didn't look like a moment. It looked like a slow normalization of moving around a protocol we don't own. We started treating L1 and L2 as toll plazas, not scenery. We built buffers into our burns. We accepted that brief, polite losses of lock weren't bugs. They were the system taking attendance. And standing on the other side of that realization was a map the public hadn't seen yet. Triangles tightening exactly when trilateration would be most effective. The Sentinel geometry trilateration into policy. Here's the simple, ugly beauty of it. 3 points beat one fortress. If your objective is to know where everything is, lock it fast, and stay quiet, you don't build a single behemoth. You lay down 3 modest nodes, space them cleanly, and let math do the heavy lifting. Equilateral triangles aren't aesthetic, they're efficient. They shrink proportionally with distance, preserve angle integrity, and deliver solutions with fewer assumptions. With timing and angle of arrival alone, 3 stations can pin a target within meters, even if none of the stations ever burns a gram of propellant to chase. Stakes first. If those equidistant lights over the ridge weren't vehicles but references, the story flips. A triangle overhead isn't a craft showing off. It's a tape measure unfolding, taking a quick set of caliper readings, then stowing itself. And if that same template sits larger at L2, L4, L5, watching the cislunar lanes, you get a layered instrument that measures outward and inward at once, like a surveyor leveling a city block while checking a mountain range in the same glance. Action. Watch how the geometry behaves under load. During heavy cislunar windows, surface reports of triangles rise near launch corridors and energy grids. Not random clusters, clean spacing, steady edges, quiet persistence. At altitude, telescopes catch faint, fixed separations that hold proportion even as apparent size changes with observer distance. Meanwhile, the anomaly dashboards light up around L1 and L2, and the polite interference we've learned to work around adopts a cadence that matches trilateration cycles. Sample, validate, handoff, idle. You can model it. Analysts did. When a node array cycles at period t, the surface echoes appear at t/3, staggered by path length differences. The captures do just that. Now the human piece. An analyst in a windowless room overlays 3 maps: energy transmission corridors, recorded triangle sightings, and logged L-point anomalies. The first 2 were supposed to be folklore. The third came from a machine that doesn't care about stories. He drags opacity sliders until the overlap pops. The equilateral spacing near surface grids scales to the equilateral spacing at cislunar altitude. Different sizes, same ratios, same internal angles. He writes local nodes indexing to cislunar references, pauses, and deletes the phrase indexing to. He replaces it with consistent with alignment. The difference matters on paper. It doesn't change what the maps are saying. Impact. Once you accept that triangles are tools, not trophies, intent clarifies. Position locking is obvious. Targeting isn't missiles, it's tasks, steering interference around fragile links, nudging trajectories back into safe basins, damping emissions that spike beyond tolerances. Masking sits on top of both. With 3 points, a network can place a moving null precisely over a transmitter's main lobe without touching the transmitter. Your device thinks it's loud. The universe hears a whisper. That's not magic. It's phased control at scale, with geometry choosing the phase delays. Microstory. A small coastal utility company rolls trucks because rural customers report TV snow and brief drops on smart meters during a clear night. A technician looks up and sees 3 steady lights, low, certainly not aircraft. He files a benign interference ticket. Weeks later, a regional space launch replays its raw spectrum logs for a vendor. There's a narrow notch moving through the band exactly when residents reported the snow. The notch's timing matches a cislunar handoff modeled by a graduate student 2 states away. None of them talk to each other. They don't have to. The triangle did the talking. Meanwhile, commercial guidance teams quietly add a wrinkle to their targeting algorithms. Rapid solver rain it when attitude sensors report transient star loss. They aren't solving for why, they're solving for when. The periods line up with what a trilateration cycle would require for multi-baseline agreement. It's mundane in the code, it's consequential on the pad. Burns start a beat earlier. Handovers happen on the half beat. The mission slips less than a second. The triangle keeps time. Here's where it gets uncomfortable. A system that can trilaterate can also draw boundaries that aren't lines on a chart, but behaviors in a sky. 3 nodes choose where precision lives and where ambiguity reigns. Inside the triangle, your position solution grows tight. Outside, your instruments feel a little drunk. The firewall and the fence stop being metaphors and start being operational modes. Protect by clarifying, contain by blurring. Both can wear the same face, 3 points, holding still. And the silence? That might be the last piece. GPS shouts down at us because it has to. A Sentinel grid points its tape measure down and its muzzle outward. No advertising, no beacons, just math sweeping across our lanes, deciding when we get clarity and when the universe gets quiet. If you stand beneath it and call that a craft, it lets you. The geometry doesn't care what we name it. It cares that the triangle closes, the clocks agree, and the corridor behaves. Firewall or fence? Protection versus containment. So which is it, shield or cage? Start with the behavior we can time. During heavy launch windows, links through the L1 and L2 shells grow polite static, not chaos. The pattern isn't random. It timetables to our burns, then relaxes. That looks like moderation, not malice. If you wanted to keep lanes safe, you'd do exactly this. Apply just enough pressure to force disciplined handovers, then step back before anyone files a failure report. That's the firewall reading. But watch the outward voice. Radio astronomers who live on the far edge of faintness have logs where the background gets surgically quieter during the same windows. Not offline shaped. The narrowbands most likely to leak our busyness outward get notched, slid, or briefly nulled. On paper, it reads like spectrum management. In practice, it's a hand on our throat, gentle, steady, and timed to our loudest moments. That's the fence reading. Stakes. If outbound emissions are being balanced, we might be living under dark forest rules without ever voting. The logic is brutal and simple. Loud is dangerous, quiet survives. In that frame, the Sentinel grid acts as a mask, letting our domestic chatter thrive while damping the parts that carry furthest. The public gets Wi-Fi. The cosmos gets a whisper. Meanwhile, the same math that keeps the corridors tidy can act as a lid when we spike. You don't need a treaty if the geometry enforces one. Action. Correlate claims, then test for timing. A university radar lab reported unexpected attenuation lobes, in coincidence with a crowded geosynchronous maintenance week. An independent SETI backend saw a notch carve through a slice of the low VHF a minute after a rideshare lit engines toward lunar space. A commercial radar network logged brief, repeatable flutter on antennas pointed sunward during a near-miss debris cascade. Each instance arrived with the same quiet signature. Equidistant overhead lights for ground witnesses, a triangle at altitude for telescopes, and that disciplined loss of lock riders learned to buffer. Now a microstory. A backyard observer catches a solar flare on a small telescope, a fast brightening at the limb, then immediately pans to a known quiet patch. 3 faint points hold a perfect spacing for 2 minutes, then dissolve. On his recording, you can hear a ham neck complaining of a thin veil that lifts as quickly as it arrived. Hours later, a satellite operator posts a bland note about temporary SNR depression on a deep space link. None of them knows the others exist. The timeline lines up anyway. Impact lives where motive hides. A firewall explains the quick handoffs, the corridor weather, the measured interference around collision events. It also explains the way certain bands recover faster than models after debris alarms, like someone upstream drains the echo. A fence explains the outward hush, the notches that follow launch surges, the surface triangles that coincide with energy grid steadies, as if domestic noise becomes the compromise for cosmic quiet. The same tool can do both jobs. Which mask you see depends on where you stand. What nobody likes to say out loud. If the grid shields us by muting us, it also reserves the right to mute inside when outside risk rises. That's where the human cost creeps in. Houses that report hauntings during big windows also log microwave spikes. Witnesses get headaches, feel nudges of nausea, and leave rooms as if steered. Flames pop from nowhere and die as fast. Those are side effects if the system steers heat and phase to draw a null. People become collateral in a macro safety plan. Another human moment. A telescope feed shows a brief, clean flare near a known debris path, too tidy for random reflection, followed by 3 stable points that hold station like nails in the sky. The flare disappears from the public archive. The triangle remains in citizen footage. Was that deflection or editing? The answer may be both. A firewall action upstream, a fence in the database, and a story that ends in a shrug. Meanwhile, agencies behave like tenants reading the landlord's moods. Space Force bakes anomaly buffers into ops. Civil aviation adopts bland phrases about spectral stewardship. Commercial firms schedule burns around times their planners won't name. None of this proves non-human origin. It proves operational reality. Rules exist in the lanes whether or not we wrote them. So choose your frame. Firewall. A guardian that dampens our clumsy broadcasts, manages collision risk, and keeps the lanes from spiraling into shrapnel without asking. Fence, a governor that sets how loud we can be, how fast we can expand, and when our links get to speak. The triangle doesn't care which word we pick. It closes, the clocks agree, and the corridor obeys. And the consequence? If the mask protects us from the unknown while restraining our reach, every mission brief now includes an unspoken negotiation. We push, it presses back just enough. Which brings us to the ground, where the pressure isn't abstract. When the grid gets close, people feel it. Ground-level pain, illness, bursts, and steering. Down here, the geometry turns into symptoms. People don't see triangles, they feel pressure behind the eyes, taste metal, and step out of rooms for reasons they can't name. When the corridors run hot above, the hot spots on the ground light up in smaller, stranger ways. Microwave spikes in living rooms, gamma blips in basements, knocks in empty halls, and little fires that start and die like misfired matches. If the grid steers energy to keep lanes safe and emissions quiet, it has to push that energy somewhere. Sometimes that somewhere is us. Stakes first. Clusters of nausea and headaches don't prove a system. But when clusters ride the cadence of known anomaly windows, map to energy corridors and aerospace routes, and resolve after the windows close, you're not dealing with haunted wallpaper. You're dealing with side effects. A physician in a Midwestern town started a private list: dizziness, ringing ears, insomnia, short fuses that didn't fit the patients. The entries stacked on nights the Skywatch channels had been buzzing. He circled dates, then noticed the consolation prize. Symptoms eased faster than flu when the lanes above went quiet again. Action. A small research team set up a low-cost sensor rig in a 2-story rental where a family complained of knocks, electronics hiccups, and headaches that made the youngest child cry at sunset. They placed broadband RF meters in the hallway, a gamma scintillator near the breaker panel, and a magnetometer beside the couch where everyone felt pushed. For 2 calm weeks, nothing. Then a weekend launch stacked with a Cislunar handoff hit the calendar. The hallway meter jumped, short bursts at centimeter wavelengths, too brief for home Wi-Fi, timed at neat intervals. The scintillator ticked twice, sharp and local. The magnetometer wobbled as if a quiet hand brushed past. The family left for a motel that night without being told. A human moment. The father came back to feed the cat and stood in the doorway while a soft knock tapped from inside the wall. 3 beats, a pause, 3 again. He walked down the hall, the RF meter on the table chirped, then the kitchen smoke alarm gave a single lonely burst and fell silent. He took the batteries out, called the team, and slept in his truck with the engine off. In the morning, the instruments read flat. 2 days later, the launch crossed L1. The house went normal, as if it had signed a temporary lease to interference. Meanwhile, fire departments keep odd records that never go viral. Small flames that lick a lamp cord without tripping a breaker. Soot kisses on drywall with no obvious spark. Mysterious origin is a phrase that placates reports and ends paperwork. But line up those nightmares against windows when the nets tighten overhead, and you start asking whether a phased null in the sky sometimes blooms on the floor. Impact sits at the intersection of protection and harm. If the Sentinel geometry wants to damp outbound noise, it can create a moving zone of reduced amplitude over a transmitter. At the edges, energy must go. If the plan is to keep aircraft links clean during a collision scare, the spillover could land near houses under a lane, tapping at pipes, warming a cable, making a person stand up and walk to another room because their stomach says move. That's steering at human scale, unintended, uncomplicated, and cruel in a domestic way. Microstory. A family leaves their home after weeks of knocks and headaches. The research team returns for one last night with the sensors. At 2:11 a.m., the RF meter draws a neat comb across a narrow band, the gamma clicks twice, and the magnetometer draws a small fat loop. 10 seconds later, 3 faint points hold steady outside the upstairs window, so dim the camera barely catches them. They don't move. They thin and fade. In the log, a note. Burn window at L2 approach began 2:05 a.m. By sunrise, the house is just a house again. The family never moves back. What nobody likes to put in print. The hot spots tend to sit where infrastructure hums, near substations, along high-capacity lines, beneath approach paths that align with outbound corridors. The system's convenience is our proximity. It's easier to steer around what already carries current. That makes sense on a whiteboard. It feels like betrayal in a living room. Meanwhile, investigators borrow the night shift discipline. They correlate, not declare. Timestamps, frequency bands, geomagnetic indices, launch logs, and witness notes stack into uncomfortable piles. The patterns don't explain intention. They do. Force and acceptance. When the grid gets close, people get moved. physically by nausea, psychologically by dread, economically by abandonment. Families sell fast, landlords repaint, and a neighborhood learns a new euphemism for invisible weather. Here's the pivot. If the firewall protects lanes by steering energy, the price is paid below by strangers who never filed a flight plan. If the fence mutes outward voice, the echo shows up in houses, hospitals, and small fires. The human calculus isn't tidy. The grid responds to us changing the sky. We live under its choices, reminded that a system optimizing for planetary quiet might harm the rooms with the best stories. Global hotspot logic, Lunar edition. Map it, and the patterns stop pretending to be folklore. Start on the ground. Nuclear corridors glow on the overlays, reactors, enrichment sites, long rail lines moving fuel. Then blink your eyes and see the same corridors mirrored in the sky by triangles that hold a beat, appear, and fade. Energy grids lace across continents, and along those high-capacity routes, the polite disturbances arrive with the cadence of cislunar windows. Aerospace lanes thread through the same geographies, and when those lanes line up with outbound arcs, the anomalies tighten like laces before a sprint. Here are the stakes. If someone or something wants layered oversight, it uses layers that already exist. Surface infrastructure concentrates power, traffic concentrates attention, and translunar arcs concentrate ambition. The Sentinel logic seems to treat those as one system, not three. When launches surge, the grid up top pulls taut. When reactors peak output or grid managers rebalance a region, triangles appear near substations like quiet instruments. When air exercises move across missile corridors, the sky geometry holds formation above as if checking margins. Layered oversight isn't a metaphor. It looks like surface, atmosphere, orbital, and cislunar stitched into one feedback loop. Action. Watch Brazil. Hydroelectric routes thread the Amazon basin like arteries. In 2025, farmers along those lines logged orbs hovering low after midnight, steady, equidistant, unhurried. Weeks later, private telescopes over the South Atlantic captured faint, fixed separations that scaled to those ground reports. On the same nights, a planned rideshare to high orbit slipped its window, citing telemetry harmonization. The public missed the link. The machine didn't. Its anomaly tiles warmed from the dams to the coast to the cislunar shells in a smooth wave. Shift to the Pacific. Naval staging areas around Guam and Hawaii become rehearsal halls for geometry. During missile detection drills, observers recorded clean triangles at altitude, their edges too crisp for drifting flares, their spacing too rigid for aircraft. Hours later, the cislunar dashboards registered brief, disciplined interference over the L1 corridor as multiple vehicles raised apogees. The timing matched like notes in a chord. If a net upstream wants to index our most kinetic theaters, it stands over the ocean lanes and the cislunar gates at the same time. Now Eastern Europe. Conflict-era maps glow with old bunkers, nuclear storage, and air defense umbrellas. Through 2024 and 2025, radar operators described small, luminous formations holding position near those arcs, never crowding commercial traffic, never colliding, simply there. On nights when satellite constellations overflew in thick trains, the formations steadied. In the hours surrounding translunar planning windows, ground reports of domestic hauntings rose in clusters beneath those arcs, then receded. Again layers, people in houses, aircraft in skyways, nodes overhead, corridors beyond the moon. One system breathing. Microstory. A substation foreman in Piranha watches his board twitch for 2 minutes, a harmless ripple, while a night shift tech steps outside and sees 3 lights holding a triangle above the river. That same hour, a small observatory in Chile notes a narrow notch drift across a band they never see disturbed. 12 hours later, a depot in Florida pushes a heavy stack towards cislunar space. The mission lists nominal and lands on time. The overlays laid together, read like a sentence, grid steady, sky measured, corridor gated, proceed. Impact. This is what layered oversight looks like when it stops hiding in acronyms. The surface layer stabilizes and absorbs. The atmospheric layer enforces polite separations, nudges interference, and passes up timing. The orbital layer buffers debris and smooths traffic peaks. The cislunar layer closes the tape measure and decides when the outward voice gets damped. Overlays of reported triangles, energy infrastructure, and L-point activity rhyme because the network behaves as one mechanism. It isn't micromanaging. It's regulating, enough pressure to keep baselines clean, enough masking to keep broadcasts quiet, enough geometry to keep position solutions honest where it matters. Another human moment. A cargo pilot on a night leg across the western Pacific watches 3 steady points hang beyond the canopy, then fade as the cabin radio takes an automatic handoff. He notes the time. Later, browsing public trackers, he sees an outbound arc through the L1 funnel at the same minute. He writes nothing. He changes nothing. He flies the next leg and calls the pattern lane weather. Meanwhile, authorities behave like they've accepted the map. Space Force folds Cislunar anomaly projections into air and maritime planning briefs. Civil grid operators receive quiet advisories about synchronization windows and keep their frequencies tidy. Commercial space firms add footnotes about corridor coordination to risk disclosures. No one says Sentinel. The geometry says enough. Here's the resolution inside the map. Global hotspots persist where sensitivity lives, nuclear corridors, energy routes, aerospace lanes, and where ambition crosses them, translunar arcs. The system responds to our pulses with measured pressure across all layers. We feel it in houses, we see it above grids, we adapt in air and orbit, and we brief it in Cislunar. The hotspots don't drift because we don't. We keep building along the same lines. The net, above and beyond, keeps holding formation, waiting for our next push to decide where to press. Quiet coordination, when governments don't blink. While the overlays told a story in geometry, the ground told it in posture. Watch the people with radios and authority when triangles appear and corridors press. They don't panic. They don't sermonize. They rearrange their tools like musicians shifting keys mid-song, and keep time with a beat they'll never name. Stakes first. If governments believed the sky was random, they'd react like it was weather. Advisories, apologies, delays. Instead, the reactions look rehearsed. A raise up before the pattern forms, lanes cleared without flight notices, telemetry rerouted along paths nobody publishes. Comm becomes the giveaway. It's coordination without attribution, a choreography for an unacknowledged partner. Action. Footage from the field shows it plainly. In a high desert range, personnel set portable arrays beneath a steady triangle, generator lights hooded, voices low. No perimeter lights, no do not enter. They measure, wait, pack, and vanish before sunrise. Across an air base, crews taxi aircraft around a sliver of runway nobody will admit goes red during certain hours. Pilots accept the ground line's word, expect congestion, though every scope says clear. Over open water, a naval formation shifts by a few miles to leave a quiet corridor where nothing visible asks for courtesy. Meanwhile, unclaimed missions slip through farside windows. A national ephemeris briefly lists an engineering experiment in a cislunar shell. Hours later, amateur trackers find nothing in the advertised orbit. Days after, a research paper about radio quiet on the far side cites improved relay conditions, as if a relay politely appeared and declined credit. The only evidence is behavior. Ground stations log pristine links during a window that, a year earlier, carried polite static. Someone coordinated. No one claimed. Microstory. Night convoy on a Tulane road near a western test range. 3 trucks, 2 masts, 1 van with windows too dark for inspections. They parked beneath a ridge. Overhead, 3 faint points hold formation like punctures in the sky. At 2:13, the convoy withdraws without headlights, leaving tire scuffs and dust. At 8 o'clock, environmental monitors report unusually clean air across the valley. Particulate counts drop, RF noise baseline smooth as glass. The logs don't list cause. They do mark time. Behavior spreads laterally. Civil aviation receives advisories with bureaucratic titles, temporary spectrum stewardship, and route planners adjust without protest. Air traffic controllers keep cadence with unable direct, expect vectors in 10, timing the bend to moments when the anomaly scores peak. At sea, a missile test shifts by half a day. A public notice cites weather. The only clouds that moved were in the dashboards. Inside the quiet, drills sharpen. A multinational exercise in Eastern Europe aligns ground-based arrays under overhead geometry during a night sortie. The formation flies perfectly within improvised air corridors. The sky holds a triangle too stable to be flares. A second team across town practices a silent switch. Handover between redundant comm paths triggered by a timer, not a failure. The network above never misbehaves. The crews below act like it might and win points for speed. The middle path emerges in the memos. Not acknowledgement, never that. Operational coexistence. Language that treats the unknown as infrastructure. Manage, buffer, synchronize. One internal note lists spectral housekeeping responsibilities. Another describes cooperative geometry awareness. The phrases sound like meetings about building maintenance. They're rules for living under a system that sometimes puts its hand on your shoulder. Microstory. A commercial launch provider receives an unbranded email with a single line. Recommend deconflict T+47:30 to T+48:00. No signature, no threat. The ops lead moves a handover by 30 seconds. The mission clears L1 without a blip. The next day, the company gets a survey about industry satisfaction with publicly available space weather forecasting. The team laughs and checks satisfied. Meanwhile, the far side choreography grows elegant. A relay listed as demonstration arrives precisely when an international radio instrument needs the moon's bulk to sing. The instrument logs the quiet it came for. The relay drifts out of public listings by the next week. No failure notice. No deorbit footage. The experiment publishes on schedule and thanks no one. A later audit notes that the night's Cislunar corridor ran without a single polite static event. Impact. This is what governance looks like when disclosure is optional and reality isn't. The calm under triangles becomes policy. Portable arrays stage beneath geometry like paramedics setting up before a marathon mile marker. Civil routes kink gently around blanks nobody draws on charts. Military drills bake unknown coordination into scenarios and never say who else was in the room. The goal isn't to solve the sky. It's to keep promises on the ground. A human moment. A duty officer briefs a shift. Quiet corridor likely between these minutes. He doesn't say why. He doesn't have to. The room nods. They've seen enough cycles to trust the timing. They build buffers, rehearse silence, and get the job done. So if the firewall is real, what's it for in 2026? The answer sits in the posture. Don't blink, don't brag, don't break. Act like you share lanes with a bigger system. Because you do. And the next theory step isn't about ghosts. It's about risk. Our broadcast footprint is exploding. The triangles aren't decoration. They're policy enforcement with math. Now put that against dark forest recalibrated. Too loud might be the only crime that matters. Here's the premise that makes people uncomfortable. If the universe rewards silence and punishes disclosure, then a grid that shapes our outbound voice isn't paranoia. It's policy at scale. Earth's broadcast footprint has exploded. Constellations hum night and day. Launch cadence spikes. Laser links stitch continents. Add every unintended leak from power systems, radars, and amateur rigs, and you get a planet louder than any moment in our history. If a dark forest logic operates beyond us, the first prudent response isn't a speech. It's a mask. Watch how the Sentinel behavior fits that frame. During surge windows, the courteous notches arrive across bands most likely to carry cleanly into interplanetary space. They don't erase communications. They rebalance them, sliding energy into domesticated channels while nipping the parts that propagate. Deep space transponders get a damp hand. Local links stay healthy. A firewall that manages collisions can share hardware with a mute that keeps us dim. One cluster of nodes, two operating modes, both justified by survival math. A human moment crystallizes it. An academic observatory schedules a long integration on a faint quasar. The night looks perfect, dry air, stable seeing. An alert pings their planning tool. Moderate cislunar congestion predicted 210 to 240. The astronomer rolls eyes, keeps the plan, and starts the exposure. 20 minutes in, the baseline flattens in a way no atmosphere explains, a narrow, surgically smooth trough that lasts 5 minutes and lifts like a curtain. Later, the same night's launch logs shows a pair of high apogee burns and a translunar injection aligning to the minute. The astronomer's data is still good, just quieter than it should be when the world shouts. Meanwhile, collision management folds neatly into the same posture. When high-orbit debris cascades threaten to amplify, the polite interference in cislunar space rises fast, then falls faster than models predict. As if the grid upstream shifts phase, trims gain, and clears room for operators to breathe. No attribution, no triumph, just outcomes. Fewer alarms, cleaner handovers, calmer rooms. A mask that breathes when we gasp. Stakes get sharper when you add the moon's blind side. L2 sits in the perfect shadow, loud to the void, quiet to us. A crown node there can index every outward lane without a press conference. It can hear what we can't, decide when our tone carries too far, and shape it so the universe hears a whisper. Add L4 and L5 as flanking references, and the triangle becomes a filter, steering hot spots away from amused giants we can't see. We experience a polite nudge. Elsewhere, something that listens gets less to judge. What nobody wants to consider. If someone built it, they already lost the argument about whether silence matters. In a universe where trust is impossible and acceleration is cheap, the safest civilization limits how much it reveals. That calculation isn't moral. It's actuarial. This is where the Sentinel posture stops looking like myth and starts looking like risk management. Enforce corridors, damp outliers, clip emissions that stack into signatures, and keep the system legible enough for us to cooperate without admitting we must. Microstory. A near-miss debris event in medium Earth orbit spikes the dashboards. For 90 minutes, tracking teams juggle conjunction notices. At the same time, Cislunar anomaly scores tick high, then decay in a clean exponential that outpaces every forecast. A junior controller whispers, "It's like someone upstream pulled the heat out of the pool." Across town, a radio astronomer mutters about unexpected recovery in bands that typically take hours to settle after storms. Neither file a report linking the two. They make their shifts on time. Impact lives in what changes next. Mission designers start treating outbound arcs like speaking in a library. Announce, whisper, finish cleanly, and hand the floor back. Scheduling tools embed quiet windows that coincide with the triangle's known cycles. Civil regulators slide bland language about spectral stewardship into guidance, the bureaucratic mask for a cosmic truth. We're not alone in the hearing range anymore. And Space Force doctrine hardens around the idea that anomalies aren't glitches to be crushed but rules to be read, as if lane markers painted themselves and our job is to stay between them. The fence reading still bites. When the mask tightens, ground-level side effects pile up. Homes nudged by microwave combs, small fires that start and stop like punctuation, headaches that keep households moving. Those harms don't disprove the logic upstream. They expose its cost. A system optimizing for planetary quiet won't pause to spare a living room. It will do the math and let people become noise it can tolerate. So this is the recalibration. Dark forest theory stops being a fiction shelf and becomes a checklist sitting beside Burns. The Sentinel grid looks less like a watcher and more like a regulator that treats our expansion and our volume as variables it moderates. Protective? Often. Restrictive? By design. And in the silence after each managed window, you can feel the shape of the bargain. We grow, but at a pace the triangle approves. We speak, but never quite as loudly as we think. Triangles as temporary anchors, not craft. We've been taught to name what we see. 3 lights hold formation, and our mouths say, a craft. But watch their behavior against the metronome we've already timed. They appear at the onset of corridor pressure, hold equidistance with ratios that don't drift, then dissolve the moment handoffs complete. Vehicles flex. These don't. They behave like fixtures that phase in, do a job, and vanish. Anchors, not ships. Stakes first. If triangles are node formations, mobile references dropped into local airspace to index against cislunar nodes, the story flips from visitation to calibration. That means each surface appearance is a temporary anchor point in a larger measuring lattice, an instrument lowering a probe into the atmosphere to close a geometry that started at L4, L5, and L2. The human eye sees edges. The system sees baselines. Action, then proof by repetition. Pilots report the same template across continents. 3 points steady in rough air, edges too clean for thermals, maintaining separation against crosswinds that buffet everything else. Thermal drones catch them colder than background on some nights, warmer on others, but always flat, no exhaust plume, no parallax appropriate to a single body. AI tools, fed hours of sky feeds and radar returns, flag the same 3-point layout at consistent scales from Phoenix to Porto Alegre to the Philippine Sea, appearing during windows we already know correlate with L-point pressure. Different cameras, different atmospheres, identical geometry. Microstory. Phoenix night, the one that filled local feeds. Phones caught a wide triangle hanging and fading. A hobbyist across town launched a thermal quad. The overlay later showed something odd. The 3 corners held temperature within a fraction of a degree for 6 minutes, steady against desert cooling. No convection trails, no heat wake. When the craft dissolved, the yard's power line hum returned to baseline. On the other side of the world, A pilot logged a triangle at altitude over the Atlantic. The airline's data link performed a pre-planned handoff precisely then. Separate events, same function. Local anchor engaged, corridor cycle closed, anchor withdrawn. Here's the mechanic that fits the math. A cislunar array needs a local phase reference to place a moving null over a noisy transmitter or to tighten a position solution at a delicate moment. Dropping 3 points at a fixed spacing provides an instant baseline with known geometry. Phase delays can be coordinated between surface anchors and high nodes to sculpt energy and precision where needed. It's not flight, it's a survey taking a breath. The triangle is a tool head, not a hull. Impact. This reframe resolves contradictions that craft can't carry. Identical apparent sizes across continents stop being absurd if the template is a fixed instrument kit, deployed in standard configurations. Lack of acceleration signatures ceases to puzzle when there's nothing to accelerate, only fields to align. The eerie comm in cabin radios during overhead triangles makes sense when the goal is to stabilize links, not dazzle spectators. And the polite interference we mapped at L1 and L2 lines up with the local anchor's clock. Sample, validate, handoff, idle. Another human moment. A medevac pilot tracking a patient across the Midwest noted 3 steady lights, holding off his port side for 2 minutes. He called Tower. Tower saw nothing on scope, suggested lights on distant highway equipment. He rolled his eyes, flew the procedure, and watched the lights thin like chalk lines in rain. Later, reviewing timestamps, the hospital's IT flagged a brief, automatic network reroute that kept telemetry live. No fanfare, just the triangle doing a job no one asked for out loud. Meanwhile, AI detections make the case brute force. Pattern recognition across public feeds isolates the triangle signature independent of context, then correlates with cislunar anomaly scores, grid load data, and scheduled burns. The match rate defies coincidence. A statistician writes, template recurrence consistent with instrument deployment, and the room goes quiet because the phrasing finally says what operators already treat as true. These are anchors. The fence reading still nips at the edges. Anchors that phase into shape outbound voice bring side effects we logged. Microwave combs in houses, headaches that move people, minor fires that kiss walls. Those harms don't negate the anchor theory. They confirm it. Any instrument that carves phase and amplitude at scale will burn off error somewhere. If the waste heat lands in a neighborhood, the anchor did its job upstream and left a bill downstairs. Resolution. Triangles aren't fleets touring our skies. They're temporary baselines, dropped where geometry demands, synchronized to a cislunar metronome, and withdrawn when the measure closes. Call them anchors, not craft, and the whole picture tightens. A regulator doesn't need ships to visit. It needs references to hold while it counts, damps, nudges, and lets us pass. And if that's right, the surge that follows explains why we're seeing more of them. We changed the sky in 2025 and 2026. The instrument responded. The 2025 to 2026 surge and the lunar pivot. It felt like someone flipped a switch. Launches that used to mark the calendar became background noise. Rideshares stacked like freight. Mega constellation planes drew bright ladders at dawn and dusk. Ground stations hummed nonstop. By mid-2025, the number that mattered wasn't how many vehicles flew. It was how much the sky changed because they flew. Every surge rippled through the layers we'd already learned to read. Surface grids tightened, air lanes bent, orbital dashboards warmed, and the cislunar anomaly tiles glowed like embers under a bellows. Stakes first. Volume isn't just traffic. It's pressure on rules we never voted on. With every burst of launches, the Sentinel geometry responded in kind, polite, precise, and unmistakably present. What had been occasional lane weather became a recurring season. If you scheduled burns towards cislunar space, you didn't ask whether the corridors would press. You asked when. Action. The Federal Aviation Administration's license graph looked like a staircase climbing without landings. Commercial manifests listed quarterly cadence like subscription deliveries. Starlink flew, Kuiper followed, national fleets filled their own planes, and boutique payloads rode the gaps. Each spike wrote the same story in the logs. Brief star tracker wandered during high apogee climbs, disciplined notches in deep space bands as L1 gates breathed, and triangle anchors phasing in over coastlines and substations right on cue. The machine didn't blink. It scored the windows, nudged handoffs, and let us pass. Micro story. A small operator won a late slot on a shared ride to high orbit, slotted between two heavy comm birds and a technology demonstrator. Their guidance chief ran a quiet sim the night before with the Anomaly tiles layered over burn timing. The tool suggested moving a handover by 20 seconds. He made the call, shrugged at the superstition, and launched. Hours later, as the stack raised apogee, the briefest lull kissed their link. The delayed handover caught, the attitude solution never hiccuped, and the payload separated clean. He wrote himself a note he'd never written before: respect corridor cycles. Meanwhile, public language softened into blandness. Sustainability matured into orbital stewardship. Debris mitigation sat beside resilience under spectral congestion. The euphemisms behaved like shock absorbers for a harder truth. We were normalizing operations inside a regulated domain. Insurers added clauses for network-induced comm degradation. Brokers asked, "Will your burns align with recommended windows?" Even the silence carried structure. Here's where the pivot became obvious. The moon stopped being a destination and turned into a calendar. Logistics plans that once treated near-rectilinear halo orbits as exotica wrote them like street names. L2 relays moved from grant proposals to procurement. National programs talked openly about farside science and cislunar depots. Every step outward brushed the same crown node we'd been circling in whispers. When plans touched L2, the Anomaly tiles brightened with a kind of inevitability. "You're building on my doorstep, I'll meet you at the fence." Microstory. A consortium scheduled a relay rehearsal to the L2 neighborhood under a mundane name. Inside their ops center, the timeline carried a block labeled Spectral Housekeeping. No one outside would ever see it. At the scheduled minute, overhead triangles held steady over two coastal downlink sites. The relay reported a brief, graceful attenuation that matched a modeled handoff. The ground switched paths without a hitch. The team clapped quietly. The public summary said, "Demonstration nominal." Behavior changed on the ground as if a new etiquette had been posted on a door. Spaceports padded ascent windows to stay in rhythm with corridor cycles. Universities running low-frequency experiments built triangle watchers into scheduling tools to avoid writing off nights. Power grid operators accepted midnight calls to hold configurations through synchronization windows, a phrase that meant the upstairs instrument planned to lean on the ducting they already owned. The net above didn't ask. It harmonized by acting first. Impact. The surge didn't just increase sightings or anomalies, it taught cadence. We expanded, and the Sentinel system matched phase, keeping lanes clean, muting our loudest moments, and shaping a tempo we adjusted to without ceremony. Sustainability language hid rules. Resilience drills hid rehearsals for coexistence. And the moon, especially the far side crown, shifted from symbol to supervisor. If you wanted to work behind it, your plan had to fit the meter. A human moment. A program manager who'd mocked lane weather spent a weekend redlining a mission profile after an unmapped notch clipped a test. He added buffers, moved handovers to the triangle's quiet side, and briefed his team. "We're not losing another sim to corridor timing." No speeches about origin. Just an admission in practice. The geometry sets the beat. By early 2026, the surge had written its verdict. We could fly more, faster, further, but only as fast as the triangle allowed. The pivot wasn't about capability. It was about consent enforced by math. And with that came the last lever we hadn't pulled yet. Why the moon is a warning, not a welcome. The Lunar clause. Why the moon is the warning. Whoever sets the rules at the moon sets the pace for everything after. Corridors aren't just routes, they're valves. And the far side crown, L2, sits like a quiet gatehouse we can't see. From there, the grid measures, moderates, and when it chooses, edits. That's why the moon reads like warning, not invitation. You don't build a toll booth at your front porch. You build it at the road that leads away. Stakes first. Control the L1 and L2 shells, and you don't need to own rockets or launch pads. You own timing. A nudge at those balances slips burns, stretches calendars, and turns ambition into compliance without a single public directive. In 2026, that's how it felt. Missions learned the etiquette or took small, expensive bruises. It wasn't punishment. It was policy, delivered by geometry. Action. A private lander team cleared every review except one bland note. Navigation review. Internally, their guidance chief had flagged something he couldn't name. Brief solver wander as the stack approached the far side handoff. He slid their window by minutes. Over two ground sites, triangles phased in. The polite notch nicked their deep space band and lifted on schedule. The lander rode the quiet side of the cycle and arrived clean. The press release thanked partners and cited standard refinements. In the raw timeline, the Crown node had stamped the ticket. Meanwhile, national plans began speaking in near-rectilinear halo orbits like locals naming streets. Farside science designs carried assumptions about pristine relay paths, assumptions the system could grant or deny without a meeting. When Cislunar depots appeared on white boards, anomaly tiles warmed precisely over the Crown approach, as if the network read our blueprints and posted ours. Microstory: an international radio instrument needed a night of perfect farside silence. A relay filed as engineering demo slid into place, never claimed credit, and held links like silk. Triangles steadied over coastal downlinks at the exact minute the instrument integrated. The paper later thanked favorable conditions. The condition was a crown that can open and close its hand. Impact: the meaning lands with a thud. If L2 is the Crown node, then 2026 looks less like first contact and more like first enforcement. Expansion becomes negotiation with a system that never speaks and never misses. Launch cadence bows to corridor cycles. Relays succeed when they fit the meter. Programs that try to muscle through find themselves living in paperwork about navigation review. Here's the clause we didn't sign but keep honoring. You can go, but you'll go on time, our time. The moon is not a prize. It's a governor with teeth, quietly teaching us that outward is permitted, not guaranteed. The meaning in plain sight. We've been circling this without saying it. The evidence doesn't add up to a visitor. It resolves into a system. Not a species in a window. A protocol in a network. Look at the layers like an engineer, not a believer. Surface sensors, those quiet anchors that phase in as triangles, close local baselines. Mid-layer relays, steady nodes that sit in the lower sky, shape links and timing. Orbital hubs, quiet managers around crowded bands, buffer debris, nudge handovers, and smooth our manic cadence. And above all of it, the Cislunar Sentinels, Crown nodes at L2 with references at L1, L4, and L5, set the tempo and decide when the outward voice needs a softer edge. This isn't a mural. It's an operating diagram you could chalk on a whiteboard. Data comes up from ground anchors, phase locked to Cislunar references. Tasks flow downward. Place a moving null, reindex a position solution, open a corridor gate exactly when a burn demands it, damp a band that would otherwise ring the interplanetary bell. The elegance isn't the hardware. It's the refusal to do more than required. No drowning links, only nudges. No permanent no-fly zones, only timed gates. No announcements, only outcomes. And we behave like tenants who figured out the lease. We add buffers. We rehearse handoffs. We time our growth to a metronome we didn't build. The dual truth is the part that stings. At scale, the system shields. It moderates collisions, draws heat out of panic, and helps us keep our own mess from cascading. That's the Guardian reading, and the logs back it. But the same geometry restrains. It trims our loudest bursts, notches our cleanest outward channels, and turns L1 and L2 into valves we must respect. That's the governor reading, and the behavior doesn't blink. Protective and restrictive can be the same act when survival math rules. A firewall and a fence can share the same 3 points. If that's right, our expansion isn't a duel with an intelligence across a table. It's a negotiation with a rule set that never changes tone. When we push, it presses back just enough to teach discipline. When we adapt, it eases. When we threaten to advertise ourselves into the unknown, it puts a hand on our throat and reminds us how far sound carries. It doesn't need to be malicious to be merciless. It just needs to optimize for quiet and stability at planetary scale, and accept the side effects in rooms we've already logged. A headache here, a nudge there, a family that leaves. The most human moment in this whole story might be the smallest. A lab whiteboard late at night, markers uncapped, coffee cold. An engineer sketches the layers, the anchors, the relays, the hubs, the Cislunar crown, and writes in block letters. Coexistence requires rules. Then they circle a single word beneath it, involuntary. Because that's the core. We didn't agree to these terms. We discovered them by bumping into them. We named them spectral stewardship, resilience, synchronization windows, lane weather. We dressed them in policy, but the rules were already there. So what's left to argue about? Origin, maybe. Whether the Sentinel Protocol began as human code that escaped our command, a machine ecology that evolved into a regulator, or a non-human infrastructure that predates our noise and only recently woke up to it. The truth is, the origin question matters less than the operational fact. The lanes behave as if governed. The crown node times our reach. The triangles close when math demands it. And across agencies, companies, and countries, the posture has converged. Don't blink, don't brag, don't break. Read the rules in the interference, then make schedule. We end where we started, under a hard-edged shadow on the moon's far side, and a trio of steady points that don't need permission. Cameras catch them. People argue names. In control rooms, nobody argues anything. They move a handover by 30 seconds and make the night. The meaning is hiding in plain sight because it isn't hiding. It's acting, and we've already folded it into our lives. If we're living under a protocol, the measure of freedom becomes how well we play inside it, how precisely we align growth with a metronome we didn't choose, and how honestly we admit that the moon in 2026 is not a destination marker. It's the silent moderator of what comes next. That's the line we crossed, the moon as a boundary that bites, not a banner we plant. If you're logging this too, help us tighten the map. Upload verifiable anomalies with timestamps and metadata. Ground truth beats rumor. Subscribe and stay with us. Next, we'll connect corridor timing to the new launch economy and the price of missing the meter. Leave the shadow hanging where it belongs. We live under it either way.